Boys and girls, welcome back to another fun-filled, action-packed, non-flipperinoed Algebra 2 Classroom video with me, Coach Goo. Today, notes number 2, factors of polynomials. So, first thing that you want to look at right here is the very top line under the objective. Once you have a polynomial in factored form, by the way, factored form is what this looks like right here, you know, with the parentheses and the factors. You can set each factor equal to 0, and that will help you find the 0 or find the solution. All right, now real quick vocabulary check. Let's see who can get these trivia questions correct. If you're given a polynomial in factored form, the solutions are also known as, there are 3 other words. Zeros, that's one of them, okay. The solution is the one they gave you. Zeros, what are 2 other words? Roots, good, and? Close, what'd you say? X what? Intercepts, very good. Because remember, on a graph, the solutions are where your graph crosses the x-axis or the x-intercepts. Very good. Now you guys got that quick. All right, so we're going to do 2 examples right here. Finding the solutions, right? So they give you a factored polynomial right there. P of x equals 3 times x minus 1 times x plus 2 times x minus 4. I need to find all the solutions. Can you tell me how many solutions there are right there? How many solutions are there going to be in example 1? 3. How did you know there's going to be 3? There's 3 x's, that's right. So, how do I find my solutions then? You don't need to do that. This is very simple. Like it says up here, set each factor equal to 0. Set each factor equal to 0. Yes, Holly, that's right. X minus 1 equals 0. Remember this? And then what else? Right? This is, remember, where you had to, originally you guys had to factor it out and then you solved for the solutions. And then? Right. Okay, so how do I find what x equals right here? Add 1, so x equals? Okay, how do I find the x right here? So x equals? How do I find the x right here? So x equals? So there are your 3 answers. X equals 1, x equals negative 2, and x equals 4. Don't need to worry about that 3 at the beginning because there's no x attached to that 3, right? So that's just a number on the outside. You just factor it out to make your calculations easier. And there it is. So we're going to do one more example to see if you really grasped this. All right, now one thing to pay attention to. Example number 2. How many solutions are there going to be? 4, that's right. Now, some people will say 3 because they forget about the one on the outside. Negative 5x, that's still going to give you a solution. Okay? So what are my 4 equations going to be? Negative 5x equals 0, right? Then? Right? And lastly? That's right. Okay, so I can find these zeros for the x plus 3 and x plus 1 very quickly. What does x equal with these 2? Right. That's right. Okay, but what about the negative 5x equals 0? How do I find what x is there? Divide by negative 5, so x equals? X equals what? It's a 0 divided by negative 5. So 0. And then over here we have 2x minus 5 equals 0. What would I do to find x here? Add 5. So I get 2x equals 5 and then? X equals? 5 over 2. It's 5 divided by 2, remember? X equals 5 over 2. There you go. So yeah, that's finding, your solutions when you're given a factored polynomial. But now here's what the next thing we have to do. Now, we're going to look at a graph, and from a graph, we're going to write a factored form of a polynomial. So what we just saw was a factored form, and then we went through it to find the solutions. Now, we're going to go from a graph into a factored form. So let's see how we would do this. So in example 3 on A, how many solutions are there to this graph?
3.
3, how'd you know that?
There's 3 points
There's 3 points where
that cross
it crosses the x-axis, right? Because remember, x-intercepts are your solutions. So what can I say? X equals what? what are my actual number values?
Negative 3.
-3,
Negative 1.
-1, and
4.
4. Those are the three x values where my graph is crossing the x-axis, right? And at -3, x equals -1, and at x equals 4. So that's how you write down your solutions, or write down your zeros, your roots, x-intercepts. But I'm supposed to make this into a factored form. So how can I change those into factors?
Make the negatives positives and the positives negatives.
So what are you actually doing?
So like x plus 3, and then x plus 1, x minus 1.
When you add 3 to the
Yeah, but what are you doing there? Like, what's the purpose of that?
trying to put 0 myself.
Yeah, you're trying to set it equal to 0. That's right. So we add 3 to both sides right here, as you said. So what do I get? X plus 3 equals 0. There's one of my factors right there, x plus 3. Next,
X plus 1.
right, x plus 1 equals 0. And yeah, x minus 4 equals 0. So there's my three factors. So I see my three factors. Now how do I write the factored polynomial?
You do like parentheses?
Right, so what's my equation going to be? How do you start off a function? F of x equals, parentheses, x plus 3, parentheses, x plus 1, and then, that's right. There you go. And that is your factor form. Yeah, that's it. Let's make sure we can do it with one more example, though. How many solutions am I going to have on this next question, though? 4, that's right, because it crosses at 4 different points. What are my 4 solutions?
X minus 3.
All right, let's write the solutions first, where we have x equals -3,
X equals 0.
x equals 0,
X equals 3.
x equals 3,
X equals 5.
x equals 5. Very good. All right, so now that I've got my solutions, what do I do with those solutions? Bless you. At 3, we're trying to set them equal to 0, right? So we have x plus 3 equals 0. And then, what about this? X equals 0, right? That one's already set equal to 0, so we don't have to do anything with that. The factor is just x. Okay, the next one, x equals 3. Subtract 3, so x minus 3 equals 0. What about this last one?
X minus 5 equals 0.
Right, subtract 5. X minus 5 equals 0. So here are my 4 factors. Oh, whoops. We got x plus 3, x minus 3, and x minus 5. So what is my factored form going to be?
F of x equals x plus 3.
Okay, so typically, you want to start with just the x, right? Because it's very easy to just write that on the outside. So just write x and then parentheses. What were you saying? X plus 3. Right? X minus 5. It really doesn't matter what order you write it in, but it's just going to be cleaner if you have the x by itself on the outside at the front, right? Rather than like an x randomly in the middle of all the other ones. That's just for the aesthetics. All right, anyways. Here we go. So that is finding your factored polynomial from a graph. So we've been dealing with factored forms, so let's take a look now at standard form. Do you guys remember what standard form of a polynomial is? Highest what? Right, highest exponent to lowest exponent. Very good. So notice that these factored forms, right, there's no exponents there, right, because it's factored out. So to get into our standard form from a factored form, we're actually going to multiply everything together. Okay? So let's take a look at example 4. Write the polynomial function in standard form with zeros of -2, 2, and 3. So it's almost the exact same as the problems we've been doing, but now at the very end, we're just going to go from factored form to standard form. Okay, so they give you 3 zeros. What can I write when they give you those zeros? X. Right, but let's start with just writing the solutions, right? Just like over here on the graphs, we started with, x equals -3, x equals -1. What can I write with these zeros right here? X equals -2, x equals 2, and x equals 3. Okay, so can you tell me the factors based on those then? x plus 2, right? And then? Right, and then what about this one? Right. Okay, so there's my three factors right there. 1, 2, 3. So what is my factored form going to be? F of x times x plus 2? Right, there we go. Okay, so that's not what the question's asking for, is it? Because the question asks for standard form. That's factored form. So now what I have to do is multiply all those factors together to get the standard form. So how do we do that? Just pick 2 parentheses and multiply them together first. So I'm just going to do x plus 2, x minus 2. Let's multiply them. How do I multiply the two polynomials together, though? Distribute. So we're going to do x times x, which is x squared. Then we're going to do 2 times x, or negative 2 times x. Yep, minus 2x. Then we have the positive 2 times x. Then we have the positive 2 times negative 2. Right, there we go. So we're going to put that in parentheses. And what can we not forget after this, though? Do not forget what's left. The other one, x minus 3. But yeah, you're right. Then we're going to simplify by combining our like terms, which would make this x squared minus 4 times x minus 3. You got to keep bringing that x minus 3 down until you've taken care of it, right? So how am I going to get my final answer then? Distribute again. That's right. So here we go. X squared times x. What's that? X cubed. Then we have x squared times negative 3. All right. Now we have the negative 4 times x. And lastly, negative 4 times negative 3 plus 12. And so there is your standard form of this equation.
That's the answer?
Yes, that is the standard form. That is the answer. Make sure you understand the difference between factored form and standard form, okay? X cubed minus 3x squared minus 4x plus 12. Let's do one more to make sure we get the hang of this. This one's shorter, though, because there's only 2 zeros. Guide me through the steps. What would you write from beginning to finish? X equals 3. X equals negative 3. Then? Okay. All right. Then? F of x? Right, because we just got our factors, right? Those are our factors. So now we can write our factored form. F of x equals? Right, and then distribute. Okay. X squared minus 9, that's right. And that is your final answer. You guys did that one fast. All right, now this is a good time to demonstrate one of these special cases here for factoring, okay? So notice our two factors are x minus 3 and x plus 3, right? See that? So what's the only difference between those two factors? There's only one thing that I see different about those two factors. Yeah, one's positive and one's negative, but everything else is the exact same, right? So that is a special case called difference of squares, which we've done before, but I'm not sure if you remember this. Difference of squares. This is a special case that can help you multiply out very quickly, but also find your factors very quickly. So when you have a difference of squares like that, first you need to recognize that it is a difference of squares. It's the exact same thing, but one's plus, one's minus, right? So then, to find out my actual answer from that, all I have to do, if it's a difference of squares, is multiply the first two numbers. So x times x, which is x squared. That's where the x squared came from, right? Then multiply the last two numbers, which would be negative 9, and there it is. That's it. That's only when you have difference of squares, right? But that also helps you go backwards really easily, because when I see this, right, x squared minus 9, I see the first term is a perfect square. I see the last term is a perfect square. I see a minus sign in between them. That lets me find my factors very quickly, because look, the first term in each parentheses is just the square root of the first term. The second term, the 3's, that's just the square root of 9. And then one's positive, one's negative. Okay? That's important because sometimes you're going to have huge numbers in front. Like what if it was like 25x squared minus 100, right? Kind of big numbers to factor out. But if you know the shortcut for difference of squares, you can get it very quickly. And we're about to look at some examples of those. So here we go. Lastly then, changing from standard form to factored form. Or in other words, we're just factoring. So this is definitely a review, but something that we always could use more practice with. All right, so write this example down. X cubed minus 2x squared minus 15x. So we need to change this standard form into factored form. So let's see if we remember the steps for factoring. What is the very first thing you have to do? Okay, so it is the X box, right? But what is the first thing you do when you are trying to factor? The A, B, C, but you got to do something before that. You always have to do something at the very beginning. Take out your X. What if there's no X though? How can you generalize your statements? What do you always check for? Greatest common factor, that's right. So what is the greatest common factor here? X. That's right. We can factor out an X from everything. So if I factor out an X, what's left?
X squared minus 6x minus 15.
Right, yeah. So you said to take out X, but that like taking out X doesn't work in every single case, right? But the GCF is like the general thing that you need to do. But yeah, you're right. The X is the GCF here. Okay, so we factored out the X there. Because remember, you can't do the X box until you have ax squared plus bx plus c form. Now we have the ax squared plus bx plus c form. Okay, so we can now start the X box with the a, b, c. What is A? Remember, these are numbers. 1. What is B? -2. And what is C? -15. Right. So now we draw the X box. Do you remember what goes in the top? A times C. Very good. Which is? And what goes in the bottom? B, which is -2. Right. How do I find the numbers that go in the side of the X box? To which ones though? They multiply to which one? -15, and they add up to -2. That's right. So what are the two numbers then? -5 and +3. There you go. All right, what do you have to make sure you do? What do you have to remember to do after you find your side numbers, just to be safe? You put what on top? So it's not just an X, because that's a simple mistake that will get you the wrong answer in certain cases. 1x? How did you say 1x? Why is it 1x? Because the A is 1, right? So on top is supposed to be A times X, remember? That's where a lot of people mess up. They'll just write X. In this case, it is the same, but it's not always going to be the same. Somebody out there? Okay. Spooky. So X is on top. All right, let's see if we can get the correct factored form. What is my final factored form then? Is that the factored form? So you set it equal to 0 if you're trying to find the solutions, right? But this one doesn't really ask you to find solutions. We're just factoring. But is that the factored form? Does this equal my original equation?
No.
Why? Because you didn't put the X, right? You see this X that you factored out at the beginning? You need to remember to put that in your final answer as well. Okay, otherwise it will be completely different. So there it is. Yes, x times f of x equals x times x minus 5 times x plus 3. All right, this next example right here, we're not going to finish it all the way because it's kind of the exact same thing, but if you should write it down just in case. X cubed minus x squared minus 12x. Let's just make sure we know what to do first. What would my very first step be? Factor out an x, right. So if I factor out an x, what's left? minus 12. That's right, okay? And so, you can work through the problem just like the last one, and in the end, your answer should be, if you want to work this out on your own later, x times x minus 4 times x plus 3. That's what your answer should end up to be. So write that if you want to try this one on your own. And the worked out, solution is going to be on Schoolology. All right, but let's take a look at some other examples to make sure we can see all the different types of problems that you could encounter. So right here, 6x squared plus 19x plus 15. What's the first thing that you're going to do? So he's talking about factoring the x out, but not all the terms have an x. So see, don't think about.
You divide it by 3.
Can you divide all these numbers by 3? You check for a GCF. Okay, GCF's not always x. Sometimes it's just a number. But anyways, in this one, there's no greatest common factor. So we go straight to ABC. So A is, B is, and C is. There we go. All right, X box. What's going to go on top? 90. Wow, that was fast. A times C, 6 times 15 is 90. What goes in the bottom? So what are my two side numbers? 10 and 9. Very good. All right, now we did this example to make sure that you finish the problem the right way. So everything's good so far. Now how do I finish the problem? You put 6x on top. Why 6x? Because A is 6. Right. So is my answer, can I finish now and say 6x plus 10?
No.
Why? What do I have to do? What x? There's no x to factor out. Divide? Not by 6.
By 3?
By 3, yes. You want to reduce. Remember, every time you have fractions, you want to reduce, or else you're going to get the wrong answer. So if I reduce the right side, 6x over 9, what does that reduce to? 2x over 3. What about the left side?
3x over 5.
Right, 3x over 5. So there we go. What's my factor form going to be here then? F of x equals parentheses? 3x what? Minus 5? Plus 5, right. There's no minus sign there, so plus 5. And then? 2x plus 3, and there it is. You see, you didn't factor anything at the beginning, right? So there's nothing in front of these factors. There we go. Boom. All right, next one. Let's do, not going to work this one all the way out, but just another example here to illustrate what you should be doing. 2x squared minus 4x minus 70. What would I do first on this problem? You would factor out a 2, right? In this case, you factor out a 2. Don't just divide it by 2, because you could do that if you're solving, but this is not solving, it's just factor. Okay, so you got to make sure that 2 is still there. So this is the same thing as 2 times x squared minus 2x minus 35, right? And then you could just work it out from there, and your answer, you would end up to be like this, equals 2 times x minus 7 times x plus 5, if you work it out all the way. I'm not gonna spend time to do that, because you can do it the exact same way as the others. But let's take a look at this example. Make sure you know how to write the answer for this one. 16x squared plus 24x plus 9. All right, on this one, is there a GCF? 3. Can you divide 16 by 3? No. So there's no GCF? All right, so we can go straight into X box. What is A? What's B? And what is C? All right. Okay, so the X box, boom. What goes in the top? 144. 16 times 9 is 144. What goes in the bottom? 24. So what are your two side numbers? 12 and 12. Very good. What's next? Right, 16x because a is 16. And then? Reduce it to what? And then? 4 over 3, right? Because you can get 8 over 6, you can divide both by 3 still. 4x over 3 on both sides here. And so what's my factored form? F of x equals parentheses 4x plus 3 times.
4x plus 3.
Right, now how can I condense this?
I'm gonna have 4x plus 3 squared.
Right, 4x plus 3 squared like this. 4x plus 3 quantity squared. And there you go. So remember, you can condense them, right? All right, our last example of the day. This is going to be a special one. Let's see if you guys can get this one. 25x squared minus 49. What do you notice about this one? There's no what? There's no x term, which means there's no b. That's right. Remember, the x term is b. Okay, there's no b. That gives you a big hint. When there's no b, you should be looking out for a special case that we did earlier today, which is, do you remember? You think you know the answer? What do you think the answer is?
5x minus 7, 5x plus 7.
Whoa, how'd you get that? That is the answer. Wow.
Because 5 times 5 is 25 and 7 times 7 is 49.
Right, so you're looking at these numbers and you're seeing that they are perfect squares, right? These are perfect squares. That means this is a difference of squares. And right, remember, you could do the x box this way, but 25 and 49 is a pretty big number, right? You would have to multiply 25 by 49. That would be in the top. Then you might have trouble finding the two side numbers as well. So in this case, it's very useful if you can recognize that it is a difference of squares. You see 25x squared? That's a perfect square, right? 5x times 5x equals 25x squared. 49? That's a perfect square. 7 times 7 is 49. You see a minus sign in between them? That tells you the difference of squares. That's why it's called that, because you're subtracting two perfect squares. And so then how do you find the terms that go inside the parentheses? As Oliver said, you take the square root of the first term, which would be 5x. Right? That's the square root of 25x squared is 5x. What's the square root of 49? 7. And then the two symbols should be plus and minus. And that's it. So this was a lot quicker than if you tried to do the x box, which a lot of people would struggle with. You know, people also struggle because then b is 0. They write a b down. They're like, what do I do? You know, so it's very good if you do recognize this shortcut, the difference of squares. But that's going to end today's notes. So until next time, see you then. Peace.